Hello everyone, in this video we will be discussing about chemical reactions and equations. So first, you would have observed many common day-to-day life activities such as melting of ice, your mother or yourself cooking food, or burning of paper. So mainly these changes that you see can be classified in two types. First is physical change and the second is chemical change. So physical change is a change in which physical properties of a substance change, but no new substance, no new chemical substance is formed during that process. So the first example of melting of ice was a physical change. So why was it a physical change? So let's first see what does physical properties mean. Physical properties include properties such as state, smell, size, shape, area and volume. In the melting of ice, only the state was changing. The ice was H2O and water was still H2O. There was no change in its chemical properties. H2O remained H2O even when it was ice and even when it was water. There were no changes in its chemical properties, but the physical properties changed. Now let's take a new example of magnesium. So if a magnesium ribbon is burnt, so a magnesium ribbon, when we say a magnesium ribbon is burnt, we mean when magnesium ribbon reacts with oxygen. So whenever magnesium ribbon reacts with oxygen or magnesium reacts with oxygen, magnesium oxide is formed. So we had Mg, which is magnesium, and O2, which was oxygen. These two react or combine to form MgO. Mg was initially Mg, there was no O in it, but when it reacted with oxygen, it had MgO. So a new chemical substance is formed. MgO has completely different properties from from the magnesium. Now similarly, let's take the example of H2O. When H2 hydrogen and O2 oxygen react, they form H2O. H2 and O2 both support combustion, meaning they are somewhat friends of fire. But water, H2O, is like the complete enemy of fire. H2 and O2 separately promote fire, whereas H2O demotivates fire and it reduces fire. So H2O had completely different properties from H2 and O2, and that is why it is also a chemical change. Now let's look at chemical reaction. A chemical reaction is just a process which involves a chemical change. Now if we have to write in an exam what does chemical reaction mean, we would write it as a chemical reaction is a process in which one or more chemical substances or elements or compounds react to form one or more elements or compounds. So if we had to write it in simple words, what I mean to say is when AB, which is the first compound, plus C, which is an element, they react together, and what they form is AC and B. This is a chemical reaction. AB was the first substance and C was the other substance. These two react to form AC and B. The first two substances which react are known as reactants, and the two substances AC and B which are formed when AB and C react, AC and B is formed, and these two things which are formed are known as products. So in the example I took of magnesium ribbon, which was Mg plus O2, which forms MgO, Mg and O2 were reactants and MgO was the product. Similarly in H2 and O2, when H2 and O2 react, H2O is formed. So H2 and O2 are reactants and H2O is the product. Now how can we, just looking at the reaction, how can we say whether it is a chemical reaction or not? So there are 4 to 6 chemical characteristics of a chemical reaction. The first is change in state, second is change in temperature, third is change in color, fourth is evolution in gas, and the fifth one is formation of precipitate. So a precipitate is a substance which is insoluble in its solution. we will learn about precipitate, what is a precipitate in double displacement reaction. But first we will look at a chemical equation. So a chemical equation is an equation, a representation of a chemical reaction. So whenever a chemical reaction is expressed using symbols and formulas of the reactants and products, we say that it is a chemical equation. So let's take the example of magnesium and oxygen. We had magnesium which reacts with oxygen to form magnesium oxide. What we call this is a word equation. This is a word equation because we are representing the reaction using words. So the actual chemical equation of this reaction would be Mg, which is the symbol of magnesium, plus O2, which is the formula of oxygen, which forms MgO, magnesium oxide. So this is the chemical equation of this reaction. Now we will look how to balance a chemical equation. So now let's look at balancing a chemical equation. So what does balancing a chemical equation mean? Balancing a chemical equation means that the number of different atoms at the left hand side is equal to the number of different atoms at the right hand side. That is, number of different atoms at the reactant side is equal to number of different atoms at the product side. So in the reactant side you have one atom of Mg, so then there is one atom of Mg, and on the product side there you also have one atom of Mg. Now for oxygen, on the reactant side you have two atoms of oxygen, and on the product side you have one. So there's something wrong with oxygen. There are two in reactants but one in products. But what we have learnt in 9th grade is that the mass can never be created nor destroyed in a chemical reaction, which is the law of conservation of mass. So according to the law of conservation of mass, this is not possible. So to balance this equation, we would have to make the number of products, the number of atoms of oxygen in the product side also 2. So what we will do is multiply this 1 by 2. So we will get 2. Now where do we put this 2 in here? We cannot insert 2 in between Mg and O. We have to put it here. Now what we get is 2 atoms of two atoms of oxygen. So oxygen is balanced. But what also happens when we are multiplying 2 with oxygen here is that Mg also gets 2 atoms. So in number of products of Mg here in products is also 2. Now again Mg is wrong, so we will have to correct Mg as well by multiplying the Mg in reactant side by 2 as well. So we will multiply Mg by 2. Now this equation is balanced. There is 2 atoms of Mg and 2 atoms of oxygen in reactants, and similarly 2 atoms of Mg in products and 2 atoms of oxygen in products. Now let's take another example. Another example is Fe, that is iron, plus H2O, water, which gives Fe3O4 plus H2, which is hydrogen gas. Now the element is iron. The element present in the entire equation is iron, hydrogen and oxygen. So we could just look at the reactant side to look at all the elements in the chemical equation. So we have iron, hydrogen and oxygen. So there are 1 atoms of iron in the reactant side and 3 in the product side. Similarly for hydrogen, we have 2 in the reactant side and 2 in the product side, and 1 oxygen in reactants and 4 oxygen in products. So let's multiply iron with 3. We get 3 atoms of iron in reactant side. Now iron is okay, iron is complete. There are 3 in reactant and 3 in products. Now for hydrogen is also complete. There's 2 in reactant and 2 in products. And now for oxygen, 1 in reactants and 4 in products. So we don't mess with products, we just have to multiply 4 in this, right? So 1 multiplied by 4, which would give us 4. But what we also see is we did get 4 atoms of oxygen, but we also got 8 atoms of hydrogen. 8 atoms of hydrogen. We are also multiplying this by 4. So we got 8. Now we would also have to balance the atoms of hydrogen in this side as well. So we will multiply this by 4 as well to get 8. Now we have a balanced equation here as well, that is 3Fe plus 4H2O, which gives Fe3O4 plus 4H2. So this entire method is known as trial and error method, and this works almost all of the times. This was all for this part, and in the next video we will look at the different types of chemical reactions, which is the combination reaction, decomposition reaction, displacement and double displacement reaction, and oxidation reduction or redox reactions.